Hello again, everyone. In this section, we're going to be looking at solving rational inequalities. So when we solve an inequality, what we're going to get is a range of possible values that satisfies that inequality. So let's just kind of do some examples to kind of show you how this is going to work. So let's say we want to solve the inequality x squared minus 4 is greater than 0. So what I want to do here is I want to first identify what are the possible locations that the polynomial y equals x squared minus 4 can change from positive to negative. Well, that's easy. Those are just the places where that graph of y equals x squared minus 4 crosses the x-axis. And we learned how to solve the zeros for the function, or the x-intercepts for the function, in the previous chapter. So all I need to do is I take my polynomial and set it equal to 0 and solve. So one way to do this is you could add 4 to both sides, square root both sides to get plus or minus 2. You could have also solved that by factoring. Some of you might have thought to do that first. That's fine as well. So what I'm going to do now is I'm going to draw my number line and draw in those 2 locations that we just found. I'm going to put an open circle at each of those locations at -2 and then again at +2. What I'm going to do then is I'm going to pick a test value in each of these 3 intervals. So I have 3 intervals. I have the values that are less than -2. I have the values between 2 and -2. And then I have the values that are greater than -2. So it doesn't matter the test value you pick in that interval, just as long as it's in that interval. So here my test value I'm going to choose is -3. Here the test value I'm going to choose is 0. And here the test value I'm going to choose is +3. So when I do -3 squared minus 4, I get 9. So here it's positive. When I plug in 0, 0 squared minus 4 is -4. So here we're negative. And when I use the test value 3, 3 squared is 9. 9 minus 4 is 5. Oops, so is that one. So it's positive. So if I go back to my original question here, I'm interested in where x squared minus 4 is positive. So it's positive on these 2 intervals. So my last step then is to translate these 2 intervals into interval notation. So because we have the left arrow captured, we know it's -∞, and then up into -2. And we use that union symbol. My next place starts at -2 and captures the right arrow, so I know it's to +∞, and we're done. Let's do another example. Let's say we have the inequality x cubed minus 4x squared plus 4x is less than or equal to 0. Okay. So again, we're going to start by taking the polynomial part and setting that equal to 0 and solving to find the places where the sign can change. So I'll begin by taking out a greatest common factor of x, and then x squared minus 4x plus 4, that factors to just x minus 2 times x minus 2 And when I set these all equal to 0, I get really just two solutions. Notice that these two are the same. So I'm going to draw my number line. I'm going to have a filled in circle for 0 and a filled in circle at 2. Why am I having a filled in circle here versus an open circle before? Here my inequality is an or equal to. Remember when we draw things on the number line, an or equal to gets a filled in circle, as opposed to the previous problem where we had a strict greater than. Again, when we draw things on the number line with a greater than, they get an open circle. Okay. So again, I have 3 intervals that I need to test. I need to test the things that are less than 0. I need to test between 0 and 2. And then I need to test things bigger than 2. So I'm going to pick -1. I'll pick +1. And then I'll pick +3 as my test values. So -1 cubed minus 4 times -1 squared plus 4 times -1. That gives me -1, -4, -4, so that gives me -9. So that's negative. So that gives me 1, -4, +4, so that gives me 1. That's positive. And then the last one, so it gives me 27 minus 36 plus 9 is negative again. 27 plus 12, excuse me, is 39 minus 36, I'm sorry, is positive. So I get 3, I think. You could do that on your calculator too. You don't have to mental math it. I don't know why I'm trying to do it with mental math. Totally unnecessary. So again, what are we looking for? We're looking for less than or equal to 0. So I'm interested in the negative parts. So again, because we have the left arrow, that's -infinity, comma, and we have a filled in circle at 0, so that's going to get the bracket. So there's my interval. But I have one other thing. I also have that filled in circle at 2. I know that between 0 and 2 it's positive, and after 2 it's positive, but right there at 2 it's equal to 0, and because we can be greater than or equal to 0, we also need to include that single value of 2. And the way we put that in is we put it in that squiggly brackets there. All right, another example. So we have x minus 4 over x plus 1. Now here, we have more than just one place where the function can change signs. It can still change signs at the x-intercepts. That doesn't change. But it can also change signs at vertical asymptotes. So here, I'm going to take the numerator, set it equal to 0. That'll get me my x-intercepts. And take the denominator and set it equal to 0. That will give me my vertical asymptotes. So I get x equals 4. This is my x-intercept. And my vertical asymptote is -1. So I'll draw my number line. Now my asymptote always gets an open circle. And because we're or equal to, my x-intercept will get a filled in circle. If this was a strict greater than, my x-intercept would still get an open circle. But because it's or equal to, it's okay for the x-intercept to be giving me a value of 0, which is what it does. So again, we're going to pick some test values. So let's pick, say, -2. Say pick 0. And then let's say pick 5. So that's going to be -2 minus 4 over -2 plus 1, which is -6 over -1, which just gives me 6. So that's positive. I'm going to have 0 minus 4 for 0 plus 1. So that's -4 over +1, which is -4. So that part's negative. I'm going to have 5 minus 4 for 5 plus 1. That's 1 over 6, so that's 1/6. That's positive. So since we're looking for greater than or equal to 0, we want this piece and then this piece. But we have to be a little bit careful because we have to look at whether our circles are open or filled. So this piece, -infinity, up to -1. And because we have an open circle, we use a parenthesis, union. And then we move to the next piece. Since we have a filled in circle here, we use a bracket up to +infinity. So we need to make sure we're being mindful about what's going on and making sure we get those brackets and parentheses correct. Our last example is the most complicated. Okay, so let's think here. First things first, we need to worry about where this can change signs. So I need to worry about where the numerator can be 0. And then where the denominator can be 0. So if I square both sides, I get x plus 4 equals 0. And I subtract 4 from both sides, I get -4. So there's my x-intercept. Here, to solve an absolute value equation, I split it into two equations. One, where I keep everything the same except I drop the absolute value symbol. And the other equation where I negate the right-hand side. But the negative of 0 is still 0, so it doesn't really matter. We just get x equals 1. So those are going to be my places that I have to worry about. Again, since we are a strict greater than, I don't have to worry about the circles. They're both going to be open. The only chance that they could be closed is when you have an or equal to inequality, and the only ones that will be closed are the zeros, the x-intercepts. Okay, so I have my two places. So let's pick a test value, say -5, and then pick another test value, let's say 0, and another test value, let's say 2. So we have the square root -5 plus 4 over -5 minus 1. Well, -5 plus 4 is -1, and the square root of -1 is I. So this is imaginary. So this is nothing. It's neither positive, it's not negative, it's imaginary. We don't care about it. This whole section is garbo because it's imaginary. So we don't care about that section. Doesn't matter which way the inequality was pointing, whether it was bigger or smaller, because we're getting imaginary out of those parts. They do not matter. Okay. So now we're going to have 0 plus 4 over absolute value of 0 plus 1. Well, 0 plus 4 is 4, and the square root of 4 is 2. And 0 plus 1 is 1, so that just gives me 2. And then let's do our other test value. Oops. Okay, so we have the square root of 2 plus 4 over the absolute value of 2 plus 1. Well, this 2 plus 4 is 6. The square root of 6 is positive, and the absolute value of 2 plus 1 is 3, so I have square root of 3 over 6. But the point of it is that this is positive and this is positive. And we have gotten very messy here. So let's do this to kind of break that up a little bit. Okay, so again, we cared about the positive stuff. So I have this piece, -4 to 1. And then I have this piece, 1 to positive infinity. And there's my answer. Why can't I go from -4 to positive infinity? Because we have an open circle here at 1. So you do need to divide this into 2 intervals. Okay, and that's it. So the homework for this section would be like 35 to 57. Yikes.